In today's video, we'll be exploring two powerful databases, SQL and Neo4j, and how they fit into the world of data warehousing. Data warehouses are crucial in today's data-driven business world. They allow companies to store, manage, and analyze massive amounts of data efficiently, providing insights that drive better decision-making. So, let's start with a few key concepts that underpin the world of data warehousing: OLTP, OLAP, and ETL. First up is OLTP, which stands for Online Transaction Processing. OLTP systems handle the daily transactions that keep businesses running, like processing sales, updating inventory, or managing customer orders. In this realm, SQL databases shine. SQL excels at handling structured data, where consistency and speed are critical. For example, a small shop or a giant retailer like Tesco uses SQL databases to manage transactions, ensuring every sale is recorded and inventory is updated in real time. On the other side, we have OLAP, or Online Analytical Processing. OLAP systems are designed for analyzing historical data, helping businesses make strategic decisions. This is where data warehouses come into play. A data warehouse stores data collected from various sources, like OLTP systems, making it easier to analyze trends over time. SQL is often used for OLAP because it allows businesses to run complex queries, aggregating data across multiple dimensions like time, product categories, or regions. For instance, Tesco might use OLAP to look at last year's sales data, analyzing customer buying patterns. But what about businesses like Netflix, where relationships between data points are key? That's where Neo4j steps in. Neo4j, a graph database, handles highly connected data, like social networks or recommendation engines, where understanding relationships is essential. For Netflix, Neo4j can analyze how users interact with content and how these relationships impact recommendations. Before we can start analyzing data in the warehouse, we need to move the data into it. This is where the ETL process comes in. ETL, which stands for Extract, Transform, and Load, is the process of extracting raw data from various sources, transforming it into a consistent format, and loading it into the data warehouse. For example, data from a small shop's sales system, likely using SQL, would be extracted, cleaned, and loaded into the data warehouse, ready for analysis. SQL plays a major role in ETL, while Neo4j might be used to model relationships between different data points during the transformation phase. Now let's take a closer look at SQL, which stands for Structured Query Language. SQL databases are the go-to solution for businesses dealing with structured data, like sales records, customer orders, or inventory data. It's been around for decades and remains a reliable choice for businesses that need consistency and accuracy. For example, a small shop would use SQL to track every sale and update its inventory in real time. SQL ensures that no transaction is missed and that every piece of data is neatly organized. Similarly, Tesco, one of the UK's largest retailers, relies heavily on SQL to handle its massive inventory, transactions, and customer data across multiple stores. SQL ensures that data is consistent and up to date, allowing Tesco to make informed decisions about restocking, pricing, and promotions. SQL's power doesn't stop at transactional systems. It's also heavily used in OLAP systems, where businesses need to analyze structured data over time. SQL databases can store large data sets in data warehouses, enabling companies to run complex queries, aggregate data, and generate reports. Imagine Tesco running a report to see how certain products performed during last year's holiday season. SQL allows them to query their warehouse, summarizing data across different locations and time periods. However, while SQL is fantastic for structured data, it does have its limitations. Some businesses have reported latency issues, especially when moving data between on-premises systems and the cloud. Encrypting the data for security can slow down communication, and manual configuration tweaks are often needed to boost performance. Additionally, businesses like Tesco might struggle with SQL's lack of support for replication between multiple sites, which would ensure high availability of their data across regions. Now let's turn our attention to Neo4j, a graph database that excels in managing highly connected data. While SQL organizes data in tables, Neo4j uses nodes, representing objects, and edges, representing the relationships between them. This makes Neo4j ideal for businesses where understanding relationships is crucial. Think social networks, recommendation systems, or fraud detection. A great example is Netflix. Netflix uses graph databases like Neo4j to power its recommendation engine. Neo4j allows Netflix to map out relationships between users, shows, and viewing habits. By understanding how certain users are connected and what similar viewers like, Netflix can recommend shows and movies with pinpoint accuracy. Another example could be a football club. Neo4j could help the club analyze relationships between players on the field, track their interactions, and understand how different players work together in real time. By mapping these relationships, Neo4j can give coaches insights into team dynamics and performance. While Neo4j shines in relationship-heavy data, there are some challenges. For businesses deploying Neo4j in on-premises environments, the initial setup can be complex, especially for teams without much experience with graph databases. Additionally, some users have noted that Neo4j lacks certain development resources, such as basic libraries for programming languages like Golang. Still, once it's up and running, Neo4j can handle vast amounts of connected data, making it indispensable for businesses like Netflix or any organization looking to analyze relationships at scale. So when should you use SQL and when should you use Neo4j? It really comes down to the type of data you're dealing with and the insights you need. For structured data like sales records, financial transactions, or inventory management, SQL is the best choice. Businesses like a small shop or Tesco would rely on SQL for day-to-day operations. SQL offers consistency, accuracy, and the ability to handle large-scale data sets efficiently. In data warehousing, SQL is perfect for running complex queries, analyzing trends, and generating reports. However, if your business is focused on relationships between data points, like tracking how users interact with products or mapping fraud networks, Neo4j is the better choice. Companies like Netflix, which need to analyze user behavior to recommend content, benefit from Neo4j's ability to traverse complex relationships quickly. Similarly, a football club might use Neo4j to analyze the interactions between players, both on and off the field, gaining insights into team dynamics and strategy. That said, each database has its own challenges. SQL may struggle with latency and data replication across sites, while Neo4j can be more complex to set up and lacks some development resources. The key is knowing what kind of data you're working with and what kind of insights you need. Let's look at how we can use SQL and Neo4j together. Interestingly, many businesses find that using both SQL and Neo4j together can give them the best of both worlds. For example, a company like Tesco might use SQL to manage structured data, things like sales transactions, customer orders, and inventory levels. Meanwhile, they could use Neo4j to map relationships between customers, products, and their buying habits, allowing them to create personalized marketing strategies. Similarly, Netflix could use SQL to manage user accounts and billing information, while using Neo4j to power their recommendation system. Neo4j helps them map user interactions and relationships, providing recommendations based on viewing patterns and similarities between users. Even a football club could benefit from using both. SQL could manage structured data like ticket sales and merchandise orders, while Neo4j could track and analyze player relationships and on-field interactions. Using both databases in tandem allows businesses to handle both structured and relationship-based data efficiently. In summary, both SQL and Neo4j are powerful databases, each excelling in different areas. SQL is your go-to for structured data and transactional systems, making it perfect for businesses like small shops, Tesco, or even football clubs that need to manage day-to-day operations. On the other hand, Neo4j shines when it comes to analyzing relationships, making it ideal for companies like Netflix, or for use cases like fraud detection or player analysis in sports. In many cases, the most effective approach is to use both SQL and Neo4j together, leveraging SQL's structure and Neo4j's relationship analysis to get the best insights possible. I hope this video has given you a better understanding of when to use SQL, Neo4j. When building a data warehouse, one of the most important decisions you'll make is choosing the right database. Your choice will depend largely on the nature of your dataset and the insights you need. Let's break it down with a few examples to help guide your decision. If your data set is highly structured and primarily numerical, SQL is likely your best choice. SQL databases are designed to handle structured data like tables of numbers, where every row and column follows a predefined schema. This makes SQL perfect for situations where the data is consistent and organized. Take financial statements as an example. Financial data, like income statements, balance sheets, and transaction logs, is mostly numerical and highly structured. Every entry follows a strict format, and accuracy is essential. In this case, SQL is ideal because it ensures data consistency, allows you to run complex calculations, and generates reports efficiently. A bank or accounting firm might use SQL in their data warehouse to store and analyze vast amounts of financial data, ensuring that every transaction, every dollar is accounted for and can be tracked with precision. However, not all data is structured or numerical. In some cases, the relationships between data points are far more important than the individual values themselves. That's where Neo4j comes in. If your data set involves complex relationships between objects, Neo4j, as a graph database, is better suited to handle those relationships. Rather than focusing on individual data points, Neo4j maps out how different pieces of data are connected to one another. Let's take the example of Netflix. In a recommendation system, it's not just the ratings of individual shows that matter, it's the relationships between users, the shows they watch, and their viewing habits. Neo4j can help Netflix analyze how different users are connected through their viewing patterns and preferences, helping to deliver personalized recommendations. Neo4j is built to handle these connections efficiently, allowing Netflix to traverse huge graphs of users and content, finding patterns that a traditional SQL database would struggle with. So when should you choose SQL? If your data is mostly numerical, transactional, and requires a strict structure, like financial records, sales data, or inventory tracking, SQL is the right choice. It offers the stability and reliability needed to ensure your data is accurate, up-to-date, and easy to query. On the other hand, when should you go with Neo4j? If your data is relationship-heavy, meaning the insights come from how different data points interact with one another, such as a recommendation engine or a social network analysis, then Neo4j is the better choice. Neo4j will allow you to easily map and query those relationships, giving you insights into patterns that are difficult to capture with SQL. To sum it up, if your data is highly structured and you need numerical precision, like in financial data, go with SQL. If your data is complex and relies on relationships between entities, like in a recommendation system, go with Neo4j. By understanding the nature of your data set and the insights you want to gain, you'll be able to choose the right database for your data warehouse and maximize the value you get from your data.